All right, last section, chapter 3 is solving inequalities involving quadratic functions. So there's two ways I'm going to show you how to do this. Option 1 is called the graphical method, which is basically more visual, and option number 2 is algebraic. So you can look at these steps to see how we would do this, but I'm actually going to do them in practice because if I just read them to you, it's not going to make any sense. But here's the idea. You're going to take we're going to take a quadratic function, so f of x is equal to ax squared plus bx plus c. And we're either going to ask you questions like this. Ax squared plus bx plus c. I want to know when that is less than 0. Or I want to know when that thing is greater than 0. Essentially what that boils down to is I'm just asking you, I want to know when the y values of this thing are negative, or I want to know when the y values of the parabola are positive. Another way of summing that up is, well, if your y values are positive, that means your graph is above the x-axis, versus if your y values are negative, your y values are below the x-axis, okay? So essentially this whole section is about when is the graph above the x-axis, when is it below the x-axis, depending on what the problem is asking us to do. Okay, so we're going to go over both of these different techniques, option 1 and option 2, and we're actually going to do both options in example number 1, okay? So I'm going to first take the graphical approach, right? So they're asking us to solve negative x squared plus 8 is greater than 2x using both methods above. So option 1 or the graphical method, let's do that first. So what we're going to do first is we're going to take negative x squared plus 8 is greater than 2x, and we're going to get the right-hand side equal to 0. So meaning I want one side to have a 0 on it and everything else on the other side. So all I'm going to do is going to subtract 2x from both sides. So then I get negative x squared minus 2x plus 8 is greater than 0. Okay, so here's what we're going to do. We're going to literally graph, we're going to take the left-hand side of this, negative x squared minus 2x plus 8. I'm going to graph this, and then I'm going to tell whether I'm going to find out where the graph is above or below the x-axis. And how do I know which one I'm trying to find? We'll talk about that in just a second. So again, all I did was take this and I just want to graph this function, which we did in the last section. Since it's already in standard form, let's do this. Let's locate the vertex of this thing, which is going to be found by using negative b over 2a technique. So we don't have to complete the square. So b is negative 2, our a is negative 1. So this becomes positive 2 in the numerator and negative 2 in the denominator, which will simplify to be a negative 1. So our vertex is negative 1, comma. Again, to find the y value of the vertex, we're just substituting in that negative 1 for all of our x values. So we have negative x squared minus 2 times by x plus 8. Again, I'm substituting in negative 1 for all of those x values. So simplifying this, becomes negative 1 squared is positive 1, but this negative is chilling on the outside here. So negative 1 plus 2 plus 8 gives me 1 plus 8, so 9. So f of negative 1 is 9. So meaning our y value of the vertex is 9. Now you already know that this thing should open down because of the leading coefficient being negative in front of that x squared. So just a rough sketch of this. I guess we need a pretty accurate one actually. So let's do this. Here's my x-axis, here's my y-axis, and I'm just gonna, here's negative 1 here, and let's just say 9 is something up here. And we know it opens down, that's my vertex. So we know it's gonna touch the x-axis, so let's actually find those 2 points. So the next thing I wanna find is, what are your x-intercepts? So x-intercepts again are found by letting f of x be 0. So again, let's just write that out again. Let f of x equal 0. You get 0 is equal to negative x squared minus 2x plus 8. Okay, and so again, we can solve this by using quadratic formula, completing the square and solving for x, or what you first should try is just to see if it factors. So usually when we try to factor this, we factor out a negative first because our leading coefficient is negative. So x squared plus 2x minus 8. And then continuing here, we'd factor the inside of this. So two numbers that multiply to be -8, but then add to be +2 would be +4 and -2. And then you would just have to set each one of these equal to 0. So the negative plays no role here. So you're basically taking x plus 4, set that equal to 0, and x minus 2, and set that equal to 0. So your x is equal to -4, your x is equal to 2, meaning you have -4, 0 as an x-intercept and 2, 0 as an x-intercept. So let me, hopefully you have that down. Okay, so I'm just going to do, again, I'm just sketching this really quick. -1, -2, -3, -4, and then 2, 0. 1, 2. That's going to draw on the scale, obviously, but here's what our parabola would look like. Okay. Now, again, I'm not even worrying about the y-intercept, which the directions will tell you that if you want a more accurate graph, you should do that. But I'll show you why I don't really care about that when they're asking me this type of question. Okay, so after we've had it graphed, the question is, okay, how do I answer, again, I'm going to box this, how do I answer this question? Okay, well, we've graphed the left-hand side of this. It's asking me, when is the left-hand side greater than 0? Another way of seeing that is it's saying, when is f of x, right, which was this -x squared minus 2x plus 8 thing we just graphed. When is f of x greater than 0? This question is asking me, when is the graph above the x-axis? That's what that question is asking me. And we can easily see that the graph is above the x-axis from here to here. Okay, so what that means is that we are going to describe it just like we do domain, where we say where we say where a graph is increasing and decreasing. That's probably a better analogy. When we say something is increasing and decreasing, we describe it from this x value to that x value. So the way that we answer this question, we say, okay, it's going to be greater than 0. So our answer, this is how the answer is going to look. The answer is going to be, it's above the x-axis from -4 to +2, not included, right? Parentheses around both, okay? Now, I'll explain when we'd have inclusions here in just a second. But again, all we did was we got one side with not equal to 0, but we have one side with a 0, and then we graphed it, and then we looked back at the original question, and it says, okay, well, if it's greater than 0, it just means when is it above the x-axis. If I were to flip this sign, like if it was less than 0, then it would ask me when is it below the x-axis, right? So now that's option number 1. So what about option number 2? Okay, option number 2 is all algebraic. So let me kind of explain how that's going to work. Again, I'm showing you both options because they're equally as important, not only visualizing it, but also knowing how to do it algebraically for more complicated things, which we'll see later on, and definitely you'll see it in calculus. Okay, so option number 2, right? So hopefully you have that. I'll pause real fast so you have that. Okay, so option number 2 works like this. You take let me just get it, you kind of want to do the same exact thing, is you want to rearrange it to get one side equal or have a 0. So I'm going to start at this position here, so I don't have to show you that step again. So we already have it down to -x squared is at -2x. -2x plus 8 is greater than 0. Okay, so we notice that it's going to be a parabola, okay? Now, what we're going to do is we're going to take this left-hand side, -x squared minus 2x plus 8, and we're going to find out where it's equal to 0, okay? Now, notice that that step in option number 1 was finding x-intercepts. So that's essentially what we're doing, okay? So we're basically finding x-intercepts of this graph, okay? So again, we're going to do the same thing. We would just to show you the steps one more time, factor out a negative to begin with, x squared plus 2x minus 8 equals 0. This would be x plus 4, x minus 2 equals 0. and then we found those numbers to be -4 and +2. Okay, so then what I want you to do is I want you to create a number line, and I just want you to place those two numbers on that number line. So place a 2 here and a -4 here. Okay, and then what I want you to do is come up with what we call test values. Okay, so I want you to come up with numbers that are in between the two numbers that you placed here. So again, I want to come up with a number, and these things are going to be called, I'm calling them test values. Take this technique in Calc 1 too, so that's why we're kind of calling them that. So if I give a number to the left of -4, I don't care what number is smaller than -4, I just some number. So I'm going to be dramatic and pick -10. And then I need a number between -4 and 2. Well, let's pick 0. And then something bigger than 2, most of you guys will pick 3, right? I just need some number. I could have picked 4, I could have picked 5 there, just anything bigger than 2, okay? And then what you're going to want to do is you're going to want to know, you're going to plug them into this and see whether or not the statement is true or false, okay? So again, that's what's coming up. That's what this, sorry. Okay, now it's not going over, okay? That's basically telling you this piece right here. Now, what I want to do real fast, it says determine the sign of each one of these things in the interval. What I want to do instead of saying true or false is I want to just know whether or not if I plug in this number, do I get a positive or a negative value for this piece here? Okay. Now, I'm going to shorthand your work here because I've actually taken this and I've factored it to this. Okay. So what I want to do is plug my test values into the factored form. So I'm going to substitute my test values into factored form. Okay, and I'll show you, it's just going to be quicker. Can you substitute it into the original? Of course you can, right? But here's what I want to point out here. So if I let x equal -10, okay, notice I want you to do this, okay? I have negative blank +4 and blank -2, right? And I want to plug in or substitute a -10 here and -10 here. Again, I'm plugging it into this guy here. Notice that that's going to work out to be, okay, this is a negative. I don't care about the number. I just want to know is it a positive or negative number. -10 + 4, negative. -10 - 2, negative. If I were to multiply a negative times a negative times a negative, that would equal some negative number, right? So here's what I want to do. I'm going to represent this right here as a negative. Okay, and then I'll show you its relevance to the graph here in just a second. What happens when I plug in 0? Okay, if I plug in 0, again, I'm substituting the factor form, so I'm negative, and then blank +4, blank -2. Okay, so I have a negative. Now I'm plugging in 0 here and 0 here. So 0 + 4, positive number. 0 - 2, negative number. So if I take a negative times by a positive times by a negative, that number should be a positive. Okay, so negative times positive, negative, but then negative times negative is going to give me a positive value, right? So I'm going to put a big old plus sign right here. And finally, when I test -3, sorry, or not -3, 3. So I have negative blank +4, blank -2, and I'm plugging in -3 into this. So this negative still out here, don't forget about that. 3 + 4, positive. And then 3 - 2, positive. But if I take a negative times a positive, my answer should be negative, right? So negative here, positive here, negative here. Those are my answers. So I put a negative here. Okay, so what do these negative, positives, and things represent? Okay, what I'm saying is that any y value, when I come up with these test values, I picked an x value between these numbers. So let me tell you what this negative represents. So what I'm saying is when I put a big negative there, I'm saying every single y value from -infinity up to -4 is negative, meaning below the x-axis. Every single y value between -4 and 2 is positive, meaning above the x-axis. And then again, from 2 to infinity or below the x-axis. So if I scroll out real quick, notice that's exactly representing this graph over here. So what's happening is from negative infinity to negative 4, that's why I'm getting a negative here. Between negative 4 and 2, plus. From 2 to infinity, negative, right? So it's basically taking the graphical aspect of this out and just showing you that, hey, all the points between negative 4 and negative 2 are positive. Anything smaller than negative 4, you have negative y values. Anything bigger than 2, you have negative y values. So without graphing it, you can use this chart to see what you're trying to answer. Now, the thing that you have to remember about this is you have to go back to the original question. It's asking you, when is this greater than 0? So then that means, okay, oh, I must want the positive versions of this. So you would say from negative 4 to 2, and that would be your answer. Of course, that's what we had the last time too. Okay, so a couple things I want to mention real fast, because this will happen on your homework as well. And it's going to happen in our next example as well, but I'm not going to do both of these. This option number 2 is probably the quicker method if you're really good at substituting in the values. And I'm telling you right now, if you substitute your test values into your factored form, you're going to get faster and faster at all this, right? Again, I noticed that I didn't care about the actual number. I just cared whether or not the value would be positive or negative, because I'm just trying to determine whether or not my y values are positive or my y values are negative. And again, my y values are positive, I'm above the x-axis. My y values are negative, I'm below the x-axis. Okay. Now, a bunch of questions usually come up, so let me talk about this really fast. The question usually becomes, hey, what happens if you have an inclusion symbol here? Like, let's say, what if this was an equal to symbol here? If that happens, that means I want to know where it's where it's above the x-axis in this case, or at the x-axis. Okay, so let me just explain what would happen if this were the case. Let's say if the original problem worked out to be x squared minus 2x plus 8 is greater than or equal to 0. Okay, we already know our answers from this, right? All I did was change this equal to part. Your answer would include your actual endpoints, negative 4 and 2. See the difference there? So if this inclusion's here for these type of quadratic inequalities, you're going to include your endpoints, because you're asking yourself, when does it hit the x-axis? Oh, well, it hits here and it's here. And when is it above the x-axis? Okay. So, and then usually the next natural question comes, okay, what if the same exact problem, what if it was that? What if it was less than 0? Okay. Well, if it was less than 0, then you're asking, when is it below the x-axis? So graphically, you can say, okay, your answer would look like this. Well, if it's below the x-axis, that'd be from negative infinity to negative 4. But then it's also below the x-axis from 2 to infinity. Okay. And then option number 2, you'd be looking at the negative versions of those signs. So so you have from negative infinity to negative 4, you have a minus sign, and from 2 to infinity, you have a negative sign. So you get the same answer. I'm just showing you 4 different versions of the same type of question, just using the same numbers. Again, if they were to throw an equal to sign right here, all that would do is include the negative 4 and include the 2, because now you can include not only where is it below, but also where it actually touches the x-axis. Okay, so let's do this one more time. I'm going to zoom out, see if you guys have that, and pause real fast. And now we just have one last example for this section. So example number 2, okay, solve the inequality x squared plus 3x minus 28. And I'm only going to use option number 2 here, because I like that one the most. And it's probably the hardest to get a handle of, but it's going to make your calc a lot easier. So again, first thing I want you to notice is that there's already one side that has a 0 on it. So what I'm going to do is I'm going to take out this, I'm just going to stare at this x squared plus 3x minus 28. I'm going to set it equal to 0. Okay, I already know it's a parabola that opens upwards. I just want to know, where does it touch the x-axis? So watch me do this a little bit quicker. So I factor this to plus 7 and minus 4. So I know that my x-intercepts are negative 7 and 4. Okay, so I'm not even graphing this. I already know that my x-intercepts are -7 and +4, right? So here's my, let me extend this a little bit. All right, that's just horrible. Let me just do it again. Okay. Draw my number line. Place -7 down. Place +4 down. Okay, and then I need test values. So -8, 0, and let's say 5. Those are my test values. Okay. So I'm going to plug them into the factored form of this. So I'm just going to look at this. Okay. So my test value of x equals -8. Okay. I'm looking at, let's just do this. Blank, 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 blank. +7 -4. Again, I'm substituting in -8 here and -8 here. So -8 plus 7, that's just, it's going to be a negative. And -8 minus 4 is also going to be negative. So a negative times a negative is going to give me a positive. So plus. Okay. X equals 0. Well, that's going to be, again, I'm plugging that into 7 minus 4. I'm plugging it into here and here. So that's going to give me a 0 plus 7 is a positive. 0 minus 4 is a negative. That's going to be a negative sign. And finally, x equals 5. Whoops. Plus 7 minus 4. And I'm plugging in a 5. So this is going to be 5 plus 7 is obviously a positive number. And my pen's not working. There it goes. Positive, and 5 minus 4 is also a positive number. So this is going to be plus as well. Okay. So once I have the chart, though, I have to go back and look at what it's asking me, right? So it's asking me, when is my graph greater than or equal to 0? Meaning, when is it positive? When is it above the x-axis? And also, since there's an equal to sign, when does it touch the x-axis? So here's my answers. I'm looking for the positive parts of this thing because of the greater than 0 thing. So my answer is going to be from -infinity to -7. Since I have this inclusion symbol, though, I can include my endpoint. And then I also have it from 4 to infinity. And that's my final answer for that. Okay, you'll get better and quicker at this. Now, I know that in the last two examples, what you notice is that this went plus, minus, plus. The other one went minus, plus, minus. Is that always going to happen? Or are they going to just keep alternating from here to here, here to here? For parabolas, yes. But I don't want you to put that into memory until I can explain a little bit more things as to why that's actually occurring. So it's not always going to be the case that you're going to go from plus, minus, plus. It's not always going to do that. There's reasons why that's happening, and we'll get more into that as we get deeper and deeper into functions throughout the whole semester, or 6 weeks in your guys' case for summer.